In this video, we're going to find the slope of perpendicular or parallel lines using the slope formula and the coordinate plane. You remember doing slope in Algebra 1. Slope describes the steepness of a line by comparing the vertical rise to the horizontal run. And we're going to find the slope in two ways, on the coordinate plane, which means on the graph, and by the slope formula. And here's your slope formula. M, we use to represent slope, is equal to y2 minus y1 over x2 minus x1. So here we have an example on the graph of finding the rise, the vertical rise, and the horizontal run between 2 points x1, y1 and x2, y2. The vertical rise is the distance in the y values, and the horizontal run is the distance in the x values. It's the change in the y values over the change in the x values. So if we see this example over here, the change in our x values is going to be from 2 to 8. Well, that distance is a positive 6, so we know our run is positive 6. Well, our change in y values, or our rise, is going to be from 3 to 6, because those are our y values, 3 and 6. So our rise is positive 3. Well, if my slope is rise over run, that means I'm going to put 3 over 6, which reduces to 1/2. So my slope of the line between those 2 points is 1/2. I don't just have to count here, I could count above. I could go from this point to this point. So I could go from right to left. It doesn't matter on the coordinate plane which point you start from to count. So here I'm going in a negative direction though, so my run is negative 6. And my rise is a negative 3. So that when I put my rise over run, it's negative 3 divided by negative 6. But I still reduce to a positive 1/2. So no matter which way you count, you should still get the same slope. Now, in order to use slope formula, you're going to use y2 minus y1 and x2 minus x1. You're actually going to use the coordinates. So using the coordinates, we get 6 minus 3, those are my two y values, over 8 minus 2, those are your two x values. You get 3 divided by 6, which is 1/2. Or you could switch it around and go from this point to this point. So 3 minus 6 is a negative 3, 2 minus 8 is a negative 6, still reduces to 1/2. So we still get that slope of 1/2 no matter whether we use the formula or whether we use the coordinate plane. The slope of that line is still the same. Okay, we want to find the slope of this line. So I'm going to count my rise, and my run is 5 and 4. So from J over and up is up to K. If I did it by the formula, I would have negative 1, negative 2 is point J, and 3, 3 is point K, so I would plug those in. 3 minus a negative 2 is y2 minus y1. 3 minus a negative 1 is x2 minus x1. And we still get 5 over 4, our rise divided by our run. So again, graphically and by the formula should give us the same answer. On this example, I am going to calculate slope by counting on my graph my rise and my run from M to L. So on M, I'm going to count to the left 3, so that's a run of negative 3. And then I'm going to rise positive 6. So my rise is 6, my run is negative 3. 6 divided by negative 3 should give me a negative 2. I'll get the same answer if I were to calculate it using the formula. So negative 2, 3 is point L. 1, negative 3 is point M. So we plug in our points. Negative 3 minus a positive 3, that gives us a negative 6. 1 minus a negative 2 is a positive 3. So this gives us negative 6 divided by positive 3. We still get a negative 2. On this example, we have a completely horizontal line. So we're still going to count rise over run. So My run from N to P is 7. However, there is no rise. My rise is 0. And 0 is a value, so we could plug that in. So my run is 7, which will be the denominator. My rise is 0. 0 divided by 7 is 0. I could use the points also. -3 minus a -3 is 0. And 3 minus a -4 is 7. And so we still get 0 divided by 7, which is a 0 slope. So those completely horizontal lines give us 0 slope. In this example, I'm going to be looking at a completely vertical line, and so I'm going to count from Q to R. So if I count down, I count -5 as my rise, but notice there's no left to right movement, so there's no run. And so in this situation, we have a -5 divided by 0. And because we cannot divide by 0 and get a defined number, that's why we describe the slope of a vertical line as undefined. And we get the same result when we plug in the formula. -4 minus 1 is a -5. 2 minus 2 is 0. And so we have those vertical lines that when we divide by 0, there's no number that we could define -5 divided by 0 as. And so all vertical lines have undefined slopes. This is a guide to show you a basic understanding of the direction of lines and what types of slopes they'll have. So when you have a line that rises from left to right, so rising from left to right, just as you would read a book from left to right, that's going to be a positive slope. If it is falling from left to right, we say that line is decreasing and it has a negative slope. All horizontal lines will have a 0 slope because there is no rise, so that numerator for rise over run would be 0. And all vertical lines have undefined slopes because there is no run, and so that denominator in rise over run would be 0. And because we can't divide by 0 and get a real number, that's why it's undefined. All right, here are some examples for you guys to try. Find the slopes of the lines containing these points. Next, we're going to talk about the relationship of parallel and perpendicular lines. So parallel lines have the same slopes. Parallel lines will never intersect. And so in order for them to never intersect, they have to have the same rise over run, and so they won't ever cross. So the slope of this line here, line M, is 4. The slope of L is also positive 4. So because they have the same slope, they have the same rise over run, and so whenever we're counting that, they will never cross. But perpendicular lines do cross. We know perpendicular lines actually make right angles. On the coordinate plane, if we want to make sure that two lines are perpendicular, we just have to look at their slopes. And their slopes have to be what are called negative reciprocals. Okay, so also the property of their slopes, when we multiply them together, we get -1. So -1/4 times 4 is a -1, and so we'd be able to say that those lines are perpendicular. We can see that line P is actually perpendicular to both of these. And that's actually our perpendicular transversal theorem. P is a transversal here for lines M and L. Alright, so we're going to be given some points and we're going to determine whether they're parallel, perpendicular, or neither. We could have lines that intersect and they don't have to be perpendicular. They don't have to make right angles. Alright, our slope of AB, if we just use the formula, we get +3. Our slope of CD is going to be a -1/3. Well, -1/3 and 3 are negative reciprocals. What that means is one is positive, one is negative, and they're the flip of one another. So they have different signs and they're the flip of one another. 3 is really 3 over 1, so they're flipped from one another. Because they are negative reciprocals, we can say that line AB is perpendicular to line CD. And we can see that from the picture also how we would be able to verify that. We would be able to count those slopes using rise over run and get the same slopes of negative 1/3 for line CD and positive 3 for AB. Okay, here's a couple of examples for you guys to try to determine whether lines AB and CD are parallel, perpendicular, or neither.